Welcome, everybody, to Stay Curious. I'm your host, Mark Marquette. So glad you've joined us from our studios inside the American Space Museum on a beautiful Chamber of Commerce fall day in downtown Titusville, Florida. Do you agree with that, my friend beside me, Terry White?
It's beautiful, but it's way too hot for fall. It's 80-some degrees outside.
It is. I went to lunch and had to run my air conditioning. I wasn't going to,
Yeah.
and I said, "Damn, I need to run my air conditioner here." And so everybody up north, cold wave hitting up there a little bit. So bundle up, but we'll bring you a warm program today. Something very unusual for our show is one, no slides.
No slides.
Marty Winkle, our co-producer over there, we're giving him a break today here on Wednesday, Thanksgiving Eve.
So you'll just have to put it up with the two of us to look at.
That's right. We got Bill Skafta. Bill's over here in the corner here. And Marty and Bill, and Marty, he's a friend of yours, Terry,
Yes.
and Marty knows him. And we'll get him on Stay Curious one day here. We always love it when guests come in. And we're going to talk about unboxing. I've got beneath my feet here something that walked into the door, all right, and they wanted to be anonymous and said, Mark, I got all this legitimately. I'll fill out the paperwork, accept my name, and you know me, so I'm leaving it. So I trusted the gentleman. I opened up the box, and oh my gosh, I said, Terry's got to unbox it. Now on YouTube, it's popular that people open up boxes and what's inside
Not
of it,
knowing
guess.
what's in them, yes.
Yeah. So we're going to do that. And so Terry's going to provide with me the dialogue of what I'm going to write up to make a wonderful thermal protection system display here in our museum. We've got a couple tiles, and I'm not going to say it's cheesy. It's the best we can do because we don't buy hardly anything for our museum anymore. So we'll get right to that, but I've got something fun. Here are, all 5 orbiters there. This is a, in fact, what's that say on the bottom? $399 was what this cost out to Space Center probably a decade ago. And we use it for this. By the way, Terry and I were at the Rocket Ranch reunion, and you saw the man that came in with all of these autographed by astronauts.
Yes.
Oh my gosh. Who was that guy? Don? I forget what his name is, but we might do that. But we have this on display now. Yes, it's $399.95. This is 1/200 scale models. And what we do is educate people about the OV numbers. The OV numbers there you see was something that Terry, that when I learned that, started learning that and committing that to memory and finally figured out OV 104 is Atlantis, just like that.
Yes.
Then I felt like I was cool with you guys, okay, and there. But we're going to tell you, for brevity, I'll have you read what the OV, we have a display here. What does the OV tail number mean? And where's OV 100 is always the big question. Terry's going to explain that on our educational part here of Stay Curious, showing
Okay. OV stands for orbiter vehicle, okay? And the tail number it's assigned number when they were building that. The first one was 101, and that was the test vehicle that they used to fit check. They'd bring it here to the VA, to KSC, and fit check it in the VAB, fit check it in the orbiter processing facility at the pad and that. So that was the one that they didn't want to do any of that type of fit checking with Columbia, since Columbia was going to fly into space.
Go ahead and read that, though.
Okay.
And then give your commentary,
The
because we want
suffix
to get the
is composed of 2 parts, the series and vehicle number.
series and vehicle number.
Okay. O was used for non-flight ready orbiters, and 1 was used for flight ready orbiters. OV201 would be the next generation orbiter. Of course, it was never built. The vehicle number is sequentially assigned within the series beginning with 1. Therefore, there can never be an OV100, as it would read Orbiter Vehicle Series 1 Vehicle 0. So that's why there was never a 100. Challenger 099 was originally a structure test article, STA. So, yeah, it was used to do structure testing while they were building Columbia and then when they decided to go ahead and make it a flight vehicle, then it was renumbered OV099. Okay, Enterprise OV-101, on the other hand, was intended to be rebuilt into a flight-capable orbiter. It was found to be cheaper to rebuild STA Challenger than OV-101, so Enterprise never flew to space.
Right, was used in the important approach and landing test. So there you have it. There is no OV-100 ever built, pieces or anything of it there. Bill, would you help us get that off of there? And
Thank you, sir.
and now you know. All right. And thank you all for chiming in today. I know you all going to love this show from Terry. Oh, how did I get rid of the names there? There's our chat. We've got, let's see who's saying hi to you. RG Jubilee. Please limit your conversations to the topic here, which is going to be tiles today. And there's not going to be many questions probably. Well, there might be, but Rosalie calls you Mr. Mustache, okay, on there. And yeah, go ahead.
I did win the mustache contest, so.
Wow, another busy day at the Lake County Spaceport on the shores of the Lake Michigan. We're printing more shuttle tile decals to shore up our inventory there, says Steve Jokums. And check out Lake County Spaceport for all your decals. You can't, our shuttle background here, green screen, you can't paint that on something, and he's got a decal for it. Tommy Usiak, thank you for your Thanksgiving call, and back at you. Dean Babcock, Dave Stangy's watching today. Happy Thanksgiving to you, Dave and Dean. And Mostly Park, can't wait to see the exhibits when it's finished. Good. Come in and shake my hand, Mostly Park. Gary Gerald, good afternoon to you. Carlton Bailey's out there at the Hacienda. Lynn Feather, she's always watching when you're on there.
Yes.
And everybody else is saying hi to each other there. So we're going to do something, like I said, no slides. We got a couple models here for Terry to show what he's talking about. And this is the box handed to me. All right. And a couple weeks, it's been a little over a week ago. I knew the gentleman, and I know he's a TPS guy. And so he handed all this to us. And let's just go with we got a model here to show where we come from. Let's go with the biggest piece given to us. Some of these have some tags on them that will tell us if they're space flown or not. This one won't, don't understand. But here's the first piece.
I don't need the tag to tell you this one flew.
Oh, did you?
Yes, yes.
Okay.
Okay. So it should have a part number on the tag, but this is a scrap tag, and no, it does not have a legible part tag on it. And the ID is,
I'm going to kind of take some of that.
it's difficult to see, but this is a flexible insulation blanket. So this one is on, if you flip it over, this one is installed on a panel so that we can remove it from the ship without
Show where on the shuttle
having
model
the
there,
debond it. I don't know, because I can't read the part number, Mark. It's not
V070.
yeah, but then I can't read the next
Yeah.
one. So that's what I need to be able to read that right there. So yeah, to find out if it's 377, like I can make out underneath, that would have been on the ohms pod.
Okay.
Yep.
The
So,
Otis pods.
Are the two pods on the back that have the orbiter maneuvering engines that they fire to slow them down when it comes time to come home.
Okay. May have to get, yeah, that's kind of rubbed off there.
Yeah.
So it had this, what's this material in the back?
That is it's like a fiberglass panel. Okay. So
Okay.
so the blanket is bonded onto there, and then where the holes are is where we would put mechanical fasteners, bolts in to hold it in place. When we
Okay.
needed to access that area to get in there to do work, we could take the bolts out and take the panel off.
396.
Yeah, yeah. And this
See
one,
there's your 703.
yeah. Well, this one tells me it was on the left-hand pod on the 14th flight of that left pod.
Yeah, Marty, I may have you do some zooming in here. That might
Yeah, we
help a little bit there.
we have the ohms pods,
So
since
this
they're
is the-
interchangeable from vehicle to vehicle. We have ohms
Zoom in.
pods that flew more than 40 missions,
Oh, wow.
more than any one orbiter flew.
Was that right?
Yes, because we put them on different orbiters.
How many ohms pods were traded to the 3 active orbiters? at any
All of
one
them were
time?
traded around.
Okay.
Yep.
Now, this feels starchy, all right, and stiff. And those of you that have been around Terry on our show here know that that is off the shelf what?
What?
The spray.
Oh, the spray. Yeah, it's a
Scotch Guard.
Oh no, the Scotch Guard what we put on the tiles and the
Oh,
blankets.
this isn't Scotch
no,
Guard too?
no, that's a C9 coating. We put it because the blanket material is soft. It's a little hard to see on the end, but it's a soft fabric. And we learned when we flew the first test blankets on Challenger that they would shred from the airflow. So once we put the C9 coating on, it's similar to whitewashing, but it stiffened the
It
outer
does,
fabric,
yeah, it's like
and
a
then would
starch.
let the airflow across it without
Okay.
tearing the fabric.
Now, how's this adhered to the fiberglass?
Okay,
plate
it
here?
is glued on with room temperature vulcanizing. That means it cures at room temperature adhesive. So that is painted on by a technician, and then they put the blanket onto it and apply pressure to it while it cures till the glue is hard.
And what about the holes sewn around there?
The holes, there's a lot of hand sewing involved in that, but all around that penetration hole. And then we don't cover that with anything. Once we put the fastener in, the blanket does a good enough job of keeping the heat away from the fastener that we don't need to.
What's the fastener made of?
Most of them are made of stainless.
Stainless steel.
Yep.
Okay. All right. Great. Can't wait to get that up and running there. So let me pull out here a couple things that are standard type of things that are. Yeah. Let's get this. These three items out there.
Okay.
Yeah. We got three. Wow. Now this has got felt reusable surface insulation written on it.
Yes.
All right. And I've got a bag of gold here. All right. And then let's talk about those two things. First,
Okay.
that's, I believe if you've watched this show, you could call that frizzy, correct?
It are.
What?
Yeah, it is. We called it frizzy for felt reusable surface insulation. So that is on top of the crew module. It's on top of the payload bay doors. It's on top of the wings, and it's on parts of the orbiter maneuvering system and that. So this is for areas that see less than 700 degrees. It's a Nomex felt that has a lot of uses outside of the space industry, and that it's used for firefighting materials. It's used when I flew in the military, my flight suit was made out of the Nomex. It's a non-flammable, and then it has the elastomer coating, and that's the only part of the insulation on the outside that is not fragile. We could literally walk on it on the wings and it would not hurt the material.
Race driving suits?
Oh yes,
stuff like
yes,
that?
yes.
That makes
After
sense?
some of the NASCAR drivers came here for a visit and we explained what we're doing, the different things, started installing this on the floorboards and firewalls for their cars, and actually brought one of the cars here and installed some of the flexible insulation blanket on it too to cut down on the heat for the drivers.
The feet would get so hot in the cockpit was
Yeah.
one thing. Their feet would be burning next to the engine and the drivetrain and all that stuff. And yeah, Jay Honeycutt had a hand in that. He told us about that. So here's
That is called a thermal control system blanket. That is what is inside the orbiter. And that-
inside the orbit.
Yeah, they control the temperature and protect
Like
the
inside the wings and stuff?
yes, inside the orbiter maneuvering system, inside the FRCS, and especially inside the payload bay doors. In the payload bay, you can't see a lot of it because we put a white cover over all of it. But yeah, there are literally, let's see, TCS, over 50 or 5,400 blankets inside there protecting that from the extreme temperature and the coldness of space.
This has got a little bit of corrugated look to it there, and Marty's he's got a question there. Marty's we've seen this looks like Kapton foil on the lunar module. Is that a similar?
Yeah, it's a similar foil of that, and it's a multi-layer polyamide film, either silver or gold, and the blankets in the payload bay are also covered with a beta cloth, a Teflon-coated fiberglass in that. But there are literally thousands of holes inside this so that it's allowed the air to pass through, so it actually has the ability to breathe. And they are more than 145,000 vent holes per square meter. So for a square meter of this material, it has over 145,000 small holes in it. So it's
Really?
yeah, they're hard to see, but if you look at it and look right in the center, you can see, you can't see through it because of the fabric that, but you can just see all the little tiny holes.
Yeah,
that are
yeah,
there.
I see. Yeah,
Yeah.
that's Marty could zoom into that. I could probably have you zoom in on some stuff, Marty. Here, it's hard to reach all the way there. You zoom in, it dynamically shows the And I see a question there from somebody. We're talking Fahrenheit, not centigrade.
Yep.
Fahrenheit. There you see what he's talking about. Those 100,000 per 3 square
Basically
foot.
3 square feet. Basically, yeah.
Wow, that's all right. Good. That's about 1.5 by 1.5 feet.
And you could tell them how heavy it is, right?
Not very heavy at all.
It feels like
They're
weighing
very light. I
weighing
got
a leaf.
scale here to check a couple of the tiles that I discovered in there, because all right, well that's good on that. So there's a lot of this on there. There's a lot of what you call shuttle batting, like a quilter would use.
Yeah, that's thermal
inside.
control system, and the other things we're handling are thermal protection system.
All right. Well, here's another.
Okay, this is the flexible insulation blanket.
Yeah.
This is one that's never been installed on the ship, and this is the same thing that was on that panel that Mark was holding up earlier. So this stands up to 1,200 degrees, and it is reusable once we put the C9 coating on it. Then
So
it
this is
applies
what
over.
could be applied here, but
Yes.
this is much thicker than what's there.
Well, they
looks like.
vary in thickness
Yeah.
from a half an inch up to 2 inches thick, depending on where they're at on the ship and how much heat they're going to see.
Yeah, that's the detail of this is worth zooming in on.
Yeah.
Now they can see.
Now Columbia was not built originally
Thank you, Marty.
with any of the flexible insulation blankets on it.
So it's a lot heavier.
Yeah, it had almost 32,000 tile on it. But when they were constructing Discovery OV-103, then they had come up with the blanket material. So we got some of the blankets here to Kennedy Space Center, and we installed them on Challenger on the lower temperature areas to test them to make sure they were capable of withstanding the rigors of space. And it turns out when it came back, it had shredded all that. Outer stitches were still there. It's hard to see there, but it had basically removed the outer fabric, but the stitch lines were still there, and the batting on the inside was gone, but it didn't overtemp the structure and that. So that's when we came up with putting the C9 coating on it to stiffen it.
Okay. All right, let's see what else we got in our little unbox it there. Pull out something there, Terry.
Hey, Mark, while you do now, we got a question from RG Jubilee.
Okay.
Is that made out of gold dust?
No, it is not. I don't know what the fabric is, but I used to think it was real gold, but it's not. So it's a.
Okay. Now, when is this safe? Should we have gotten gloves?
I brought some, but you're all right.
Okay, we're okay. If you got some gloves. So this is something.
The only thing you had to worry about was the first thing we took out of the box.
Oh,
The rest of this won't hurt you in the condition it's in.
okay, good. Well, now here is an interesting piece. Okay, and once again, we're looking, as Terry's looking at at this, the first thing a trained eye does is
Look at the part number, and by the shape of this tile,
now
and the
VO
70
always means
191
space shuttle.
Yes, VO70 stands
Vehicle,
yeah,
orbiter,
yep.
and then what's the 70?
70 is the designation for space shuttle,
Okay.
for orbiter.
Okay.
Sorry.
All right. And then 191 tells you
Where it's at. This is
the
a
location on
this
the
is a
shuttle.
wing. This one would be on the landing gear door. This one's got it open, but for the main landing gear door, and you can tell the beveled edge so that it compresses the thing. Let me see the other side of it and see what else it says. No, on the outside of the tile, it's got part number. Okay, it's okay. This one was off of the right wing, 191-108, and it was built originally for Endeavor for its 18th flight.
Really?
Yes.
Okay. And you tell Endeavor is
Turn
105.
around so you can read it again. Nope, turn around so you can read it.
Oh, I got
Yeah.
you there.
Say
Okay.
right wing, and then 5,
Uh-huh.
5 for the tail number 5, and then the 18 for its 18th flight.
Up there at the top. Right wing.
Yep.
5 for the orbiter 105 and 18 for the 18th flight. And then what's this other?
That's its actual part number,
Wow. How about that? Okay.
or actual
And
dash
what's
number.
this 7 object?
Oh, well, that's its serial number. The
Okay.
digit down at the bottom is a serial number, and the other last nomenclature up here, 303A, that is the process that built that tile. In other words, we didn't like the way the one fit that was on there when we took it off, so we did a process 303 to fabricate a new tile.
Okay, now what's interesting about it is this is chalky on the back, very smooth, like a bowling ball almost on the front here. And you see the line of demarcation.
Yeah.
So what's going on here?
That smoothness is the reaction cured glass coating. So that's like rubbing a piece of glass. That's why it's so smooth. And that is sprayed on by a technician by hand. And what they do is calculate the weight of the tile, and then he has to put so much of that paint on based on the weight of the tile. So the technician, it's all about their skill in doing that. So there's no way to measure the thickness of the paint that's going on there other than the technician has practiced over and over and over again and does it correctly.
This tile weighs 10.5 ounces. I got a little scale here, 10.5 ounces. And this is, you can see it's made to only one piece of the jigsaw puzzle.
Yep.
And you're saying this goes on one of the
Landing gear doors.
landing gear doors back here. By the
Jason,
way, I couldn't find one with the doors open. This one doesn't. But look whose collection this came from. Still got Joanne Morgan on the bottom there.
yeah.
The great Joanne Morgan, engineer, first lady engineer in the Apollo.
Yeah, you can't
launch
even see the
control.
doors on this little model either,
Yeah.
but it would be right here on the wing, and this one was a right wing, so it would be on this one right here.
Yeah, I can barely see the doors there.
Yep.
In this model. Oh, wait, these doors do come out. Oh, I thought that worked out. Okay.
Okay, and oddly
Learn
enough,
something new about the museum every time. Here, let's drop those babies down and get the broom crew here to open this back up.
the broom crew closes
The
doors.
broom-
They
yeah,
don't
broom
open
crew
them.
closes it. They don't open it. But reverse engineer the broom crew. There we go. Now I'm gonna pull that one out. Good. Okay, yeah, we got some wheels there. I'll get the front one down here in a minute.
Sorry about that, Mark. When I look at it closer now, that is not off the landing gear. That is further out on the wing because of the shape of it. But this tile is got 5 sides that are built, and the 6th side has not been machined. So this bottom right here, once this is all built and coated in that, then they go and they machine this down to where that white material cuts down to only about 1/10 of an inch.
All right, let's get that wheel down there. Can't get that wheel down there, but
Yeah.
excellent. So you're changing your.
Yeah,
in
it's
the
not
back-
it's not a landing gear. It's further back on the right wing, so it will be back in this zone
Okay.
on the lower surface.
Way cool piece though. Really cool piece. Let me set that aside there. And we're unboxing here with Terry White a couple tiles that have come in. Here's
Okay, this one is off of the vertical stabilizer. So this one would go around and go on there, and this side would be along the leading edge, so it would be up here on the vertical. And
fascinating. No,
Yeah.
that's a nice piece
Yeah,
to have.
so it has a 2-plane bonding surface. So this one would get the strain isolator pad here, and it would be bonded on 2 different planes.
So would there be the other side of it match
Yes,
to,
and they
to cover the
yeah, and then
down the middle?
yeah, and then there would be just this part here, and then the next one up would be installed this way. So you rotate it up the vertical.
So 2 of this width is the width of the vertical stabilizer.
Yes.
If I had one on this
Yeah,
side,
yeah. Well, the vertical stabilizer would rest right in between.
I should have a yardstick with me here to tell. But this weighs. Let's see. This one weighs.
I didn't weigh the individual.
This one.
That'd be really light. That one's 9 pounds per cubic foot
Yeah,
of
this
material.
doesn't even. This isn't even 1/10 of an ounce.
Yeah,
That's less than an ounce. Wow.
it's 94% air.
Now we got scrap on there. Scrap is
that
stamped
was-
on there.
Yep,
That's why we can have it.
That's why what we stamped on them when it was no longer certified for
Here,
flight.
unbox it. Terry White unboxing some tiles, the thermal protection system that came through our front door. And this is how we get things for eBay, for our auctions, or our collection. And we look at everything that comes in. We tell people we'll take anything because we'd rather throw it away and then you throw it away. So
I may have handled this particular tile years ago.
is that right?
That come off of the, it was never installed, but that one was built for the nose landing gear door. It tells me the 391 tells me it's a forward fuselage
There's the door right underneath
part number, and the 041 is the array. So that is on, when you go to look at the door, that is, some of them are on the door and some of them are on the structure that go at the start of the door. Then followed behind them would be the 391043s and then the 391045. So we break it down into different assemblies.
This is heavy.
That one ought to be 21 pounds per cubic foot. So we had multiple densities of tile. So, you know, we had AETB 8 tiles that were 8 pounds per cubic foot, LI 900, which were 9 pounds per cubic foot. And then we had Fricky, and we had the Breathe, the Boeing rigid insulation that was 18 pounds per cubic foot.
It's not giving me something's gone wrong on the scale. Of course, tested it before we got on. Here, let me. Oh, there we are. This is 1 pound 9 ounces. 1 pound 9 ounces. Okay, and this other tile here, comparable in size. Okay, 1 pound 9 ounces. This one is 10 ounces. So this one's a full pound heavier than the one I have in my hand here.
Because it's a lot denser tile. The material in it is denser.
Uh-huh.
Okay. And something unique about this one too is this one takes a design gap filler. So when we're installing the tile, we put a special pad in between because this is some of the hottest tile on the ship. That's why you see it's 4 inches thick, because it's going to see the most heat. And those gap fillers go in between it. And the tile actually has a lip on it, and that allows that gap filler to stay in. So the gap filler would be about 180 thousandths thick, but the gap between the tiles would only be 35 thousandths of an inch. So the gap filler could not come out. It's captive in there.
I see a couple good questions there, but I'll answer one and say hi to Connor. Hey, Connor. You're there with your grandpa Mark, huh? Grandpa Thel. Say hi to Connor.
Hey, how you doing today?
Yeah.
Getting ready for some turkey tomorrow?
There you go, Connor. Thank you for watching Stay Curious. Marty got a couple questions there that look right up our guest Terry White's alley.
Got a question from Mostly Parked. What's the total weight of all the tiles on the shuttle?
The total weight, I don't have that figure with me, but it is compared to the entire weight of the vehicle. That the TPS, all of it, is only like 8% of the vehicle's weight.
Which is 100 tons.
Yes.
So 200,000
Yeah.
pounds times 8% is about 16,000
Yeah,
pounds.
and out of that, the heaviest part is the leading edge of the wing, the reinforced carbon on the wings. That is extremely heavy, and that makes up the most weight on the thermal protection system.
Mm-hmm.
The blankets, the frizzy, and that are all extremely lightweight. And like I said, the tiles are as well.
Now that came off. I couldn't match that part number.
That one came off of the first tile we were holding.
Oh,
yeah. That one that's got the big white thickness on the bottom.
okay, gotcha. Yeah. Okay, good. This one. This goes with HRSI tile.
Yeah.
What does HR?
High temperature reusable surface insulation.
Okay. These are the tags.
Yep. And this tag was, okay, this one was scrapped in January of 02.
Okay. Yeah, zoom in on this, Marty. This is some minutia that Steve Jokums loves. Just not an innocuous tag. This tells so much about, there we go, the vehicle. All right, VO right there, 1911-08. And you've got what I find interesting and don't overlook is right here is the stamp.
Yes.
And the date.
From the
Okay.
person filling out the scrap stamp.
Yep, and everybody had their little stamps, didn't they?
Yes.
And then this is even the form number on the bottom here, government form number.
Still got your
so
stamp,
this was
Bill?
an unusable parts tag condemned on June 24th, 02. All right. And there you got another one there. Keep that in there, Marty. Let me go with this is how this stuff came in. Just like this, right there.
That's how it went out. We bagged in Ziploc bags all the parts that were going to scrap.
So this was scrapped in
01.
October 01. And what does that tell you where the vehicle it came from?
I don't know. You have to let me see the tag.
Yeah.
Okay, this doesn't tell me the vehicle it was built for. It tells me where it goes on the ship, but it doesn't tell me the vehicle.
All right. So
Let me-
unbox this.
Let me look at the rest of it and see. Okay, this one tells me more. Okay, if we look at the part number, and then we'll show it to him again. This
Well, Marty's right there. Let's zoom in on for him there.
Okay. If you're looking at the part number, it reads forward 425. Okay. This was for the forward section of the ship. That's what this part number is built for. The 4 means it was for tail number OV104. The 25 tells you it was for the 25th flight. The 4574 tells you the document that authorized the building of this tile since the original design tile didn't fit, and the 303B is the process we use to build this tile. But this is a 391034 451 that tells me this goes on the lower forward back in this zone on the lower surface right there. I can't tell by this without the drawing whether it's left or right. And then the last 6 digits is just the tile serial number. And we could track it by that information all the way back to the original bag of sand that this tile came from.
Now, a question I have about this tile, these tiles. This one here, by the way, look at the green screen behind me, and that will keep this. This is this is 6 ounces. Yeah, and this is the one that was 10 ounces. So this is 10 ounces. This is 6 ounces. So Terry, looking at the green screen behind us,
Okay.
what are the holes in the middle and what's coming out of those holes?
Okay.
And why aren't they on this?
Okay. These tile were never installed and they have never flown.
That we
Okay.
have here in our
Yeah,
collection.
they have never been installed.
Okay.
Okay. Yeah. And that one is heavier than that because we haven't machined that 6th side yet. Okay. So half that material would be removed. So that tile would be lighter if we were actually going to
Okay.
use it. Okay. And you can see the
And they
difference.
weren't used because
They didn't fit some reason or not. I don't know without the document to say why they weren't used.
okay. So
Okay.
that's my tip off that they weren't flown, folks. Is
Yeah.
there's no patina on them, but if you watch Terry talk about the show, you know what the
Yeah.
holes in the middle are for.
I mean, this one,
Helps with the-
yeah, this one could have been the fact that why it got scrapped. It could have been anything, but it shows no indication of ever being fit on the ship. So it tells me this one may have been scrapped because it didn't gain the weight properly when it was coated. There's a multitude of reasons why it could have been scrapped. But the tile here behind us that have flown, we discovered early in the program that the waterproofing was baked out of the tile on re-entry. And the tile being 94% air could hold a lot of water. And we found it out because the water was expanding and actually blowing chunks out of the tile. So we had to come up with a method to re-waterproof them. And that was the final one that worked the best, where we actually purposely made a hole through the coating of the tile. And then we used a needleless injection gun to inject a small amount of dimethyl ethyl silicate, DMES, into the tile. It absorbed right into the tile, and the tile was re-waterproofed. We also had to do it with the blanket, but the blanket we had to make multiple holes. We had to do every 6 inches on center. We had to do the holes across there to re-waterproof the blankets. The only thing is the blankets were in cooler areas, so sometimes it took 2 or 3 flights to bake the waterproofing out. So we would have to do a water test. So before we went and re-waterproof it, we'd go up there with little squeeze bottles and put drops on there. If they absorbed, then we would re-waterproof it. If they didn't, then we'd go on.
Now I'm going to be a devil's advocate here. Waterproofing. We didn't fly the shuttle in the rain.
No, but we did set it to pad in the rain. So
Aha.
yeah. So and the tile, it didn't really work like a sponge, but still when the water got on the tile and then got into it, it added a lot of weight.
Marty Winkle, who wants to add to this program on that UCX family microphone?
And we have 3 questions, Mark. First one's from Dean Babcock. What is the gap filler made of?
Okay, the gap filler is made out of a fabric, and I didn't bring one with me today. I have one in my have one in my thing I carry around. But there's multitude of gap fillers, and some of them are coated with RTV, that they're a a silica fiber and cloth, and then we coat them with RTV and we install them in gaps between the tiles. Some of them are made with a pillow. Some of them actually have layers of Inconel foil on the inside. And again, they have an emissivity coating on them to help protect them. So there's just a multitude of different types of gap fillers and different sizes. And some of them, the technician just made a template of what he needed and went over there and cut the material to the size he needed and went and installed it.
All right, a handcrafted space shuttle.
It is. It is.
Handcrafted.
The majority of the
space
TPS work is done by hand.
That's fascinating. I hope you're fascinated learning about this, breaking down these numbers. That's what we're going to do in the displays. I'm going to copy them, and you can put down what that is, and we'll put arrows to what each of those numbers mean on there. So go ahead, Marty, with another question.
Okay, another question from Dean Babcock. How was the scrap material to have been disposed of? If not to be disposed of, why would the pieces have been kept?
Well, in a lot of cases, the scrap tiles were actually shredded. They would put in like a big paper shredder, and shred it into little pieces and that. But a lot of them were scrapped, and if it didn't fit one orbiter, sometimes we stored them in case it would fit another orbiter in that. So at the end of the program, we had like 19,000 tiles in the VAB that were stored, and I don't know what happened to all of them, but the scrap tiles were supposed to go down to Ransom Road, which is a scrap facility here, and be disposed of. Some of them were inadvertently sold to people, which was against the NASA policy, but there are some people that actually have flown tiles that they bought through the scrap system. But yeah, basically they were supposed to be destroyed.
I see a bunch of good questions there for you today. Take it away, Marty.
Okay, next one's from Mostly Parked. Was the fixed side machine on site?
Yes,
Okay.
yes, it was.
What's that mean?
That means,
Six-side
well,
machine.
when they were satisfied with the way it was, then the back shop would take and then flip it over, because that's the side that held it where they're doing all the coating and the initial 5-sided machining. So then when you have to remove the material from the 6th side, then they take it to another machine, and basically they grind it down just like sanding a piece of wood that you need to fit. But there are many times that I took ones that had that 6th side that needed machining and did it right in the shop on the vehicle floor, and actually finished to make sure it was sanded perfectly to that spot on the vehicle with a piece of sandpaper on the structure, and gently move the tile back just a little tiny bit at a time till we got the thing sanded so that it was perfectly flush with the adjacent tile.
Excellent. Another one, Marty?
Yeah, from Robert Law. Can these tiles be damaged easily if you press them with your fingers, or are they hard?
They are more fragile than an eggshell. Pick one up again, and you can see by this guy handling it and Mark handling it and that. So you look at all these corners and you see the little tiny chips and stuff on the corner. Grab that bigger one down there, Mark. That one.
Yeah, this one's got a lot of chips on it.
Yeah, and see this one?
We're trying not to do that. But
It's probably through the handling and that, but it doesn't take anything at all, to do that. If it wasn't for it's going in a display, I'd just show you that all you got to do is press on a little bit and it comes off. I tell people more fragile than an eggshell.
Yeah, but it's not like that fragile. I can't pound on it. Gotta. Got a little pitch to it there.
Yeah, it does.
Yeah, okay.
Different
Go ahead,
tiles,
Marty. I
different
think
sounds.
you got another question or
There
two.
you go. Or two. Next one's from Janet Kretsch. Does compression with atmosphere on re-entry pack the tiles tighter, or is there more chance they will fail? What makes the entire tile surface capable of withstanding the plasma bubble?
Well, like I said, it's 94% air, but the tile is actually a rigid material and it does not compress. You can crush it, but you basically can't compress it like you can compress a piece of foam or anything else. It does not.
No, it's not flexible.
Yeah,
It does. It's feel. I don't know.
Yeah, and it doesn't expand and it doesn't contract. but it does move. All of the tiles are glued onto the ship with a special pad between the bottom of the tile and the skin of the ship, because if you notice when you're flying on an airplane, the skin on that wing is flexing in that. The orbiter flexed, but the tile is rigid. It does not flex. So that special pad, and it's called a strain isolator pad, it isolates the strain from the vehicle so that it's not. So they don't move much, but I could actually go out there and put my hands on the tile and move the tile, especially all of these 6x6 that you see up here. You could move them around. So, and
Hey,
that was
Marty, yeah.
that was one of the tests that they came up with to find out, as well as the bond verification attempting to pull the tile back off, that, well, maybe a tile's not properly bonded, so we have to go up and wiggle it. You know, like I said, they move, but is it move too much? So we actually created certified wigglers that had to have the cert to go out there and wiggle the tile. And
Certified employees called the Wigglers
Yeah,
are
and-
out there
yeah,
under the belly like here moving tiles around.
your friend Ann Miklos was one.
Was she?
Was that the only job they had?
Huh? Oh no, she was a TPS engineer, but no, so there were certain ones
She was
like
a
that.
regular.
And I used to dispute their stuff a lot. So they'd say, "Oh well, no, this was loose." I said, "No, that one's not loose. This was fine." I said, "No, that was loose." And I'd come up with a reason to take it off, and sure enough, it wasn't a good bond. But they'd say, "Well, this one," I said, "You may be certified, but I've been doing a lot longer than any of you." So
Hey, Marty, did you see the White House is watching?
I did see
White House
that.
on
On Merritt Island.
Yeah.
Merritt Island watching the Terry White House.
Yep.
Yeah. Yeah, well, thank you. Hope Grandpa or Dad's making you all proud here.
Another
And,
question.
Yeah, I saw another good question there.
Yeah, Lynn Feather is asking, how long did it take to waterproof tiles?
I never calculated the number of hours, but since it was a hazardous operation, we had to close the building to everyone else. So we would do major shoots, and the waterproofers would come in after everybody else was out of the building, and they would generally inject the waterproofing on a 12-hour shift on the weekends and that. And then we had to let it outgas for so many hours, and then safety would come in and make sure the building was able to be occupied again. And so sometimes they would do small shoots, which didn't take long, but when we do a big 12-hour shoot in that, we'd do it on a Saturday night, and we couldn't even open the bay till Monday morning.
Wow, good questions there. Mostly parked. Rosalie wants to know what's the gap between the tiles.
It depends where you're at on the ship. The tightest gap was up on the nose landing gear door, and that gap had to be at least 19 thousandths of an inch, but could not exceed 31 thousandths of an inch. So it only had 12 thousandths of an inch to deal with. Now on the upper surface, some areas the gap was actually 200 thousandths, just slightly less than a quarter of an inch.
Oh, great questions. We just got a couple more things to unbox that came in through our door last week. I saved them for Terry to look at them, and what a wealth of knowledge we've learned about these tiles. Cliff Watson, hello to you, brother, down in Saturday morning in Pomona. How's everything down in Australia, mate? Warming up a little bit as they're getting into their middle of their
Summertime.
springtime there.
Yeah.
So this is very light. Looks like a Twinkie. Okay, except I'm not going to eat it. Kind of spongy. Very similar to that foam insulation foam that you squirt out of the can. So
But that is not for the orbiter.
that is not
That
for
looks to me like a piece of foam for the external tank.
That's
Okay.
what I
Now we
guessed it.
did use foam like that, but not this. Of course, this was basically a sprayed on thing. We use foam blocks to replicate a tile, and we would make it exactly fit what the engineer wanted for that particular tile, and then we would send it to the back shop, and they would trace that and build us a tile exactly to the pattern we built.
So
But that
not
looks
sure where that now,
No, that looks like external
how
tank.
about the thickness?
The external tank has 4 or 5 different kinds of foam, and it has multi thicknesses of foam. So
Mhm.
I have no idea.
Horrible idea, that foam. That's what caused the problems, and we dodged a lot of problems. You better believe it. They're thinking over 10% of the shuttles that pod that went into the wing of Columbia,
Yeah.
fell off on there. Now this one's very heavy. It's it's almost 3 pounds.
That's cast aluminum. That's why it's heavy. Okay, once we glue a tile on the ship,
All right, this has got a whole. This is some handwritten Jed Clampett tile there. Look at the Marty. Why don't you zoom in on this?
handwritten because the guy put it in there while the Illumicast hadn't set up yet.
Okay, there we go.
Let me feel it. So, or may
yeah,
have just inscribed it after, but no. So
Keep it
yeah.
there, Marty.
Yeah.
We're good.
So,
Yeah.
okay, after we install a tile on the ship and the glue is cured, we have to attempt to pull it back off of the ship. Depending on where it's at on the ship is how much most of them we pulled to 10 pounds per square inch. So one like that, which basically we'd pull that thing to about 200 pounds to attempt to pull it back off.
This is a tile.
No,
Oh,
that's
okay.
what we use to pull test it. We couldn't pull the tile
Oh.
itself without damaging it. So this one was cast exactly.
Okay, let's get one of those small tiles up
Yep.
here, and I got to visualize this. There we
Okay,
go, brother.
so one of the small
this is on the ship.
Yeah. So what we would do was cast this before we glued it on the ship. The guy at the back shop would make a framework around here, and he would cast this exactly to match the tile so that we didn't damage the tile on that. Then we would put a piece of the strain isolator pad on the center of the tile, so we do it, and we would put a gasket around the outside. Then when it came over the floor after it was bonded, then the technicians over there would put a load cell on here and hold this thing on by vacuum. So they attach a vacuum hose to this, and it's held to the tile by vacuum. And then we have a tool with a load cell on it that attempts to pull that tile back off, and it has a range that you have to get to ensure that it's on there. And plus, while they're pulling it, they have to look for deflection, just in case you got a corner that didn't bond. So if one corner wants to deflect more than the others, then you have a suspect, not a good bond, and we would have to remove the tile off. Remove the tile.
You would have thousands of these,
Thousands of those.
proprietary for each tile. Just to
But
pull it
only for
off.
that tile. Only for that tile.
Wow, and this is almost 3 pounds. That's interesting. I'd like to
Yeah, but
see
remember,
a picture of that being
there was
used.
only a few flows where we removed a thousand.
Now there's
more.
a threaded in the middle there.
Yes, it's
Right.
and we held it up there with tooling, and we put this load cell on there, and then pulled it.
Huh. So we
And
should
we had
probably display this something like that.
And we had a special crew that did that.
Special crew.
Well, they did other things too, but yeah, not
Did
everybody.
they follow the wiggle crew around?
No,
No. Okay.
no, we didn't always do the wiggle
The
crew.
wiggle crew.
Yeah.
Aren't the wiggles a kids thing?
Yeah.
And there are grandkids,
Yeah.
they're wiggling,
Yep.
wiggling. Well, hope you. That's it. That's our unboxed treasure trove here. That's,
Okay, Bill's got a question for
Yeah,
us.
Bill.
Can you tell us a little bit about step and gap?
Okay. Well, yeah, that's part of the thing that people never understood or
What do
never
you
even realized we did. But it's really important that the tile have the correct gap once it's installed, and that it be flush to the adjacent tile around it. So after every tile is installed, we had to go out there and measure that tile. Yeah.
Just for example.
Yeah, and we'd have to measure the gap using non-metallic feeler gauge in that. It's called shims. And then we also had to measure the flushness across here to make sure they were flush. The reason that's so important is, especially on the lower surface, when you're coming back in, if you have a step in a tile and the airflow's coming across there and it disrupts that flow of air, then you get the effect of the air starts doing this, and it looks for a place to get in, and it finds a place further back. And what it is that disrupting the flow of air causes the orbiter to get hotter. The orbiter is only designed to peak heat for a short period of time. If you disrupt that flow of air, it's called tripping the boundary layer, then you start heating it sooner than it should. You can't just lower the nose and come home faster. That's not going to work. So you actually are going to overtemp some area of the vehicle because you have a step condition. So once we did the step and gap, if it wasn't acceptable, we'd have to crunch that tile out and build another one that had the proper, or eventually we came up with an ability to remove some of the coating and actually sand it to flushness and reharden the area where we'd remove the coating.
I was holding up the foam off the ET, and we have mostly part commented woodpecker food. Well, maybe for one woodpecker. At one
Yeah, they didn't like they didn't like the tile, but they liked the tank.
That's right. That's right. That's right. So, wow, Marty, you see anything else there we need to clear up there?
Yeah, we have two more questions.
Okay.
Got a question from Carlton Bailey. maybe I missed it, but how did the gap filler come out on, was it Atlantis mission?
No, it was
Steve
Discovery,
Robinson.
return to flight. Okay. What it is the gap filler, and I wish I'd have brought one, but they are thin and they get installed in the gap, and they're so thin that they only have a very small bonding surface. So it doesn't take much to pull one out. We only pull tested them to like 4 ounces, so we weren't pulling them hard. Okay. But in past flights, we had used RTD coated gap fillers, and if one of them protruded a little bit, stuck out between the tiles, it would burn off on re-entry. But then we'd gone to a better gap filler that was ceramic, and we knew the ceramic gap filler would not burn off. So again, we were going to trip that boundary layer. So what we had to do was, or what they had to do was send Steve Robinson out on a spacewalk, and we knew by the photos that they sent us that all he had to do was reach down there and grab the gap filler with his gloved hand, and it would come right out, which it did. So he pulled the gap fillers out. Yeah, it was sticking up like that, and all he had to do was take and pull them out. And the gap fillers were as thin as this parts tag. They were up to 6 layers, but they were as thin as the parts tag. So, yep.
Excellent. Good question.
When he got out of the orbiter on the ground, he came over to me and he says, "Here, I'm giving you these." He gave me the gap fillers, but eventually they came and took them from me. And they're supposed to be in the Smithsonian, so I got to go up there and check one day.
We'll make a road trip and check that out. Well, awesome show. Thank you so much, everybody, for making this a great show. Go ahead, Marty.
Yeah, I don't quite understand his question.
They
It's
don't
coming from
answer.
John Doe. Is that like the tile that got scratched up and exposed Columbia to the burn-up? I think he may be talking about the foam.
Well, yeah, the foam is what hit the leading edge of the wing for Columbia. It didn't hit the tiles. It hit the reinforced carbon
Right in
material, and that does
the
see
left side.
3,000 degrees on re-entry, and it knocked a hole, very large hole, through the reinforced carbon, let the superheated plasma enter the wing and melted the wing from the inside out, and that's what caused the loss of the orbiter.
Yeah, absolutely. Good. Thanks for all your questions there. Thank you all for watching today. Mitch Rothman joined in. He's wishing us a happy Thanksgiving, as we are wishing you a happy Thanksgiving. A program today that we didn't do any slides, and Marty had to give me the roster here on just a regular notebook paper there. So why don't you do the honors and your wonderful voice there, and thank everybody for watching on this.
Okay, our Jubilee, and we've met before, I believe. Haven't I met him in
That's Rosalie.
okay, Rosalie.
She was
okay,
out
okay.
at the Sands
Yep.
memorabilia show.
Yep. Steve Jokums, Tom Usiak, Dean Babcock, Dave Strange, mostly Park.
Yep.
Okay. Gary Jarrell, Carlton Bailey, Lynn Feather, Tom Celentano.
Yep.
Okay. Robert Law, my sister Peggy Hurlbert, and she's coming to my house for dinner tomorrow.
All right.
And, Mark Tell, Ace Boogie Stacks, and at the Merritt Island White House, my wife Pat. So Cliff Watson, and my wife will be there for dinner tomorrow too, since she's fixing it.
Yeah, there you go.
John Doe and Mitch Rothman.
All right. Thank
Sounds
you all
like-
for watching.
Sounds like the
there.
White House kids didn't tune in, or if they did, they didn't notify us. So
The White House kids on Merritt Island there.
no, they're out in Colorado
Oh,
and
right,
Baton
right, yes.
Rouge. Yeah.
Right. Janet Gretsch has got a question there, Marty. It looks like that doesn't apply to what we're talking about, Janet, on shuttles here today.
I think it does.
On the thermal protection.
What is it?
I think it does, Mark. Was there more chance of detachment from the shuttle performed?
Oh, I didn't see tile. I thought she was talking about detachment of the orbiter from
No. It's
what
a-
about running the? She's asking about the SCA transporting the shuttle. Aren't you, Janet? There. Thanks for your question
I
there.
think she's talking about re-entry, Mark.
Okay.
All right, go ahead. Do the
Go ahead.
question, Marty.
Was there more chance of detachment from the shuttle perform TMA turns to line up with the runway at the Cape?
No, no, there was no. It's the worst it sees is, way up there before, it's doing the radical turning and it's just getting into the atmosphere, and that I think that's where it sees the most stress. Once it gets down here over Florida, then it's slowed down quite a bit, and it's a matter of the airspeed, just like a commercial airliner was. So, when it's this close, it's not a thing. But we didn't lose tiles for that. We lost tiles on STS1 because we hadn't hardened the bottom. We hadn't densified the tile that we needed to. So we lost tiles that came off, but they came off through the vibrations and that, and then, some of the airflow. But nope, the tiles did a very good job of staying on. We lost big portions of tiles from being impacted by foam. So.
Well, Terry, what do you think about this little collection of tiles that walked into our
You have
door
a bunch
here?
of unique ones, so yeah, all over the ship.
Good, yes.
So whoever collected them went around and got all the
Well,
different
we're
ones they
going
needed.
to have your help and
Yeah.
Miklos and write up where exactly they are with arrows going on a
Yeah,
ship.
we should
where
be
they
able
go
to go out there with the binoculars and look at Atlantis and take some good pictures zooming in up there.
Oh
and tell
yeah, we could
exactly,
actually
tell exactly
go
where
out
they're
there
at.
with you one day and show there. That's awesome. So thank you all for watching today. We've had a good Thanksgiving week. Hope that you all have a safe Thanksgiving. Tomorrow we are not going to have a show on Friday, so Marty and I will be back with you on Monday as we take a little time off and reboot to get ready for the big holiday time. So hope that you can
Don't
come
go
back.
shopping. The stores are squirrely already today.
Are they already? Well, you was out there shopping for me and Marty already. God
Uh-huh.
bless you there.
Nope, getting things for dinner.
But when you gonna go see your granddaughter?
Sometime next month. Waiting to see what Travis's schedule is when he's going to be there. So.
Travis, his son, is he still over in?
No, he got to Colorado Springs last night.
Oh, good.
Yeah,
So
the
he's
Army
in
sent-
Cheyenne Mountain.
Yeah, the Army sent him back for a couple of weeks
His
of
son
training.
Travis.
Yeah, he's been
4
stationed.
tours of duty, right?
This is his 5th deployment. So yeah,
Gosh,
yeah.
God bless him. All right, and Rebecca, your daughter, and your grandkids, and Rebecca, I got a hankering for that gumbo. You don't have to add the fish to it. I got plenty over here.
She
But,
just
it's
she just
delicious.
did a great presentation at Veterans Day since she's a veteran. But out there they had a special presentation thing, and she did a 45-minute speech, and
Wow,
the
your family's
yeah,
amazing.
and for 400 people, and they just applauded her. They really enjoyed her
Wow.
speech and that. So
Terry's daughter was a sub hunter.
yep, in the U.S. Navy for 13 years. So.
So that's amazing. Now she's a big A+ mom out there. So.
Yep.
Thank you, my friend. Always
Sure.
great. We hope that you find time in December to talk about something. We always
Okay.
enjoy it as everybody here chiming in. A great program. We really are amazed at the treasures that just walk in our door every day. It's sort of like Christmas for me. And Anita, will say, Mark, I took some more stuff in. It's in the room. And but this one I took in personally because somebody wanted to make sure it was going to be used right away. So thank you all so much. Thank you, Marty, for a terrific job today as usual. Hope you enjoy your family. He's got a lot of local family here in the region here. And Bill, thanks having you in here. Bill Skepta. All right, we'll have Bill on the show here. He's off camera, but thanks again, my friend. Appreciate all that you do to promote the museum.
He's working on some stuff for your museum too.
Good. Well, everybody, have a happy Thanksgiving and enjoy your weekend as I am. And we'll see you Monday. Until then, I'm Mark Marquette on behalf of Terry White and everyone here at the museum. Wishing you a happy Thanksgiving and saying we can't wait to see you next week to bridge the space between us.